This video is intended to go along with section 7.8 in your note packet. Please fill in your notes and pause the video when needed. In this example, a ski club charters a bus that normally costs $80 per person. A group discount reduces the fare by $2 for each ticket sold. The more tickets sold, the lower the per-person fare. There are 31 seats in the bus, including one seat for the driver. What size of group would maximize the bus company's revenue? The first thing we need to be concerned with is what the domain for this problem will be. Since there are only 31 seats and one of them is for the driver, what are the different number of people we can have going on the ski trip? So that would mean that the lowest number we could have is 0, but that wouldn't really be a group. So let's say 0 is less than x, less than or equal to 30. Or 0 is less than x, less than 31. Consider what would be the revenue if 10 people went on the trip. So we need to look at the cost per person. If 10 people go on the trip, it's going to reduce the cost by $2 for each person that's going on the trip. So we'll end up having a $60 for each person. Since 10 people are going, it will be a reduction of $20. So 80 minus the 2 times 10, or 80 minus 20. To calculate the revenue, we would want to take the cost per person and multiply it by the number of people going on the trip. So the revenue for 10 people going on the trip would be 10 times the $60 per person. And 10 times 60 is going to give us $600 in revenue. Now let's look at the problem in general. What size of a group would maximize the bus company's revenue? Well, maximize usually means we need to find a maximum or a vertex. But in order to find the vertex, we need the function. So first we write a revenue function for a group of X people, remembering that the standard fee is $80 per person, but is reduced by $2 for every person that goes. We need to write a function in terms of x. Let's start with the per person charge, or the cost per person. This would be 80 minus 2x. Now we need to look at the revenue function. Remember, that's the number of people going times the cost. So again, our cost was 80 minus 2x. Multiply that by the number of people going, which is x. So x times 80 minus 2x, the cost per person. And this will give us, if we expand it out and distribute, 80x minus 2x squared. And then we could write that in standard form, negative 2x squared plus 80x. Looking at our function in standard form, the negative 2x squared plus 80x means we have a downward facing parabola, and we want to find the maximum revenue. So our maximum, again, would be the vertex, which in our parabola is the peak over here. So to find the vertex, we have x equals negative b over 2a. Our b is 80 and our a is negative 2. So if we plug those in, we get negative times 80 over 2 times negative 2, or negative 80 over negative 4. So negative 80 divided by negative 4 is going to give us positive 20. This would mean 20 people is the group size to maximize the revenue. If we put 20 into our revenue function, we can find how much revenue we can make. So by substituting 20 into the revenue function, we will end up with $800 in revenue if 20 people go, and that would be the maximum revenue the company could get. Take a look at these problems from your textbook. On the next few slides, I have included the solutions. Please feel free to pause the video to check your solution to question 15. For question 17, there are a lot of components. Please pause the video to check each part. Thank you for watching.